Seen from above, the northern sector of the Adriatic Sea has an elongated shape, and it can be noticed that the color of the waters on the Italian side is lighter, due to a gentle slope of the seabed. This feature is very rare on the Mediterranean coast. Therefore, this area grants privilege to reconstruct the changes in sea level during the geological past. The level of the Adriatic Sea has significantly changed during the last million years in relation to the climatic cycles that took place every 100,000 years approximately, alternating cold periods called glaciations with relatively warm periods called interglacials. The first evidence of a glaciation that also involved the Alps dates back to the Middle Pleistocene, about 800,000 years ago. The penultimate glacial period ended approximately 135,000 years ago, and in the subsequent interglacial, the temperature was about 2 or 3 degrees centigrade higher than today, while the sea level was between 3 and 9 meters above the current one. There were flora and fauna that are no longer present, such as boxwood and zilkova plants, which can be found today in the areas of subtropical Asia. The last glaciation began approximately 116,000 years ago and had its maximum expansion between 29,000 and 11,000 years ago, in the period called the last glacial maximum. With water trapped in the glaciers, there was an advance of the Adriatic coastline. The northern part of the sea was emerged and occupied by a large steppe plain with characteristics comparable with the current territory of the Altai Mountains in southwestern Siberia. Herds of large herbivores lived in this natural environment, and movements between the Italian area and the current Dalmatia were very easy. In the subsequent deglaciation period, the sea level rose rapidly with an average of 2.5 meters per century, thanks to the progressive rise in temperature, which about 11,700 years ago had already risen by 4 degrees centigrade. The sea thus arrived again in the Gulf of Trieste between 9,500 and 9,000 years ago, creating a coastline very similar to today's. Temporary coastal system developed that isolated lagoon areas and created a network of channels similar to the current one. The rise of the sea, which succeeded that of 9,000 years ago, submerged them, leaving faint signs in today's sandy areas, between 30 and 15 meters deep, that fishermen called tegnue, trezze and grebani. Between about 7,500 and 6,000 years ago, the Grado Marano Lagoon started to form thanks to the deltaic deposits at the mouth of Tagliamento, Isonzo, and Torre rivers, which isolated the lagoon from the sea. Since about 5,500 years ago, even the groundwater-fed rivers underwent a rise in level, and in their final stretch, they became estuaries, which in some cases became lagoon channels. In this area there was a large settlement during the late Bronze Age, and it was possible to reconstruct that the sea level between 3,550 and 3,200 years ago was between minus 2.2 and minus 1.8 meters below the current. In the current Grado Marano Lagoon, it is possible to see the remains of some buildings from the Roman era, 1st century BC and 2nd century AD, that are now submerged about 1 meter below sea level. Until the 6th century AD, the mouth of Tagliamento River was about 10 kilometers west of the present. Important changes over the 4 succeeding centuries brought it to the current course. From 600 AD to the present day, its mouth has advanced towards the sea by about 3 kilometers. Approximately 1,000 years ago, the coastline must have already been very similar to the current one. In the 17th century, maps of Venetian cartographers The island that separates the Adriatic from the Grado Murano lagoon are roughly the same and have the same names as today. In the first half of the 20th century, the so-called integral reclamation was carried out over large areas of the territory. Today, in Friuli, there are more than 20 square kilometers below sea level, which are kept dry thanks to dewatering pump waterworks and a network of artificial canals. In large areas of these lands, the soil has undergone a rather rapid lowering due to the so-called accelerated artificial subsidence, a compaction of sediments drained of water, which has dropped the altitudes by as much as 2 meters in less than a century. Between 1999 and 2020, the sea level rose on average by about 3 millimeters per year, while a century ago the value was 1 millimeter per year. We are witnessing an acceleration due to global warming, where polar glaciers are melting much faster than in the past, releasing large quantities of water into the oceans that increase their volume. Climate model forecasts calculate that the oceans will rise between 28 and 56 centimeters by 2100. Some detailed studies forecast an elevation of about 50 centimeters near Rijeka and almost 100 centimeters near Venice by that date. We will have to deal with rising sea levels and therefore act promptly, both by making a cultural change that allows a slowdown as suggested by the 2030 agenda, and by intervening on the land reclamation systems already present to get prepared and keep the territory dry.